All right, boys. Are you ready? Look at this. I'm going to open a few papers and I'm going to show you what I want to be teaching you, okay? Are you ready? Vic, are you ready? All right, let's quickly go through it. Look at this. So, the things I want to teach you are we are going to finish our probability and do some questions from the exam. And then we are going to look at mean. So I want you two to be ready. I'll be asking you questions. Remember, we do the same thing. We interchange, okay? When it comes to answers. AT, you answer one, Vic, you answer another one. AT, you answer one, Vic, you answer another one. AT, you answer one, Vic, you answer, as we move. What are the two things we are looking at, guys? Guys, what are the... Yes, we're going to finish probability. Then we'll talk about this word mean. It has a lot of aspects to it. So I'll need you to be very good. Okay, so I'm going to go to the first question to show you. We have a lot of questions, well, a lot of papers, which I'll... Right. Look at this question. Can AT, can you read the question? No, the question. Thank you. The question is calculate an estimate of the mean. This is the question. Whatever is here, this is data. The question is here. Calculate an estimate of the mean. Massive. Okay. Vic, can you answer this one? Can you read this one? The question, please. The question, please. Yes, the question starts here. The probability of picking a yellow sweet or a pink sweet is 0.4. Complete the table. That's the question. Okay. So this is probability, right? So this question is on probability, right? Good. What about the other one we saw? What is it on? Mean. Is this a Cambridge Law secondary checkpoint paper? Is it? Maths, paper 2. You do paper 1 and paper 2. Here's another paper 2. That one was from 2024. Here's another one, a little bit old. 2020. Vic, can you read the question, please? Calculate his mean score. So this is on mean, right? AT, can you read this one? So this is on probability, right? Because it starts here. The table shows information about probabilities. calculate the value of x. Then work out the probability. So this is on probability, right? Can you see that? Both of you? And is this a lower secondary checkpoint maths paper? Can you see? Is this a Cambridge lower secondary checkpoint maths paper? Right. What does this question say? Mm-hmm. B. Thank you. The what? Thank you. Okay. So it's fine. We've seen the questions. We're going to cover them. Let's start. First of all, before I do here, let's finish the very last questions we did. 8, 9, and 10. It's just a quick revision of the assignment. Are you ready? Right. Let's do it. Right. Can you are you seeing? Atlet, Vic. Good. Let's get to work. First question. Complete, copy and complete the tree diagram. So let's quickly do it. Tree diagrams, not a problem. So number 8A. Copy and complete the tree diagram. You do that. You do that. You say this is red. This is not red. We are copying and completing this one. This is the tree diagram they want us to copy and complete. So this is for the first P. Then we go again like this. And this is second. Second. This is red. This is not red. This is red. This is not red. Are you seeing? Okay. So now let's go. Red 0.3. Here for the second 0.6. We know that usually for the first and for the second it would be different. Now let's compare and complete. But we know that here this is red for the second, and here this is red for the second again. So the value which is here is always going to be the same one here. Now let's complete the diagram. What we know is that this other one, this one and this one should add to give you 1, right? This one and this one should add to give you 1. So what would be this not red? Vic? What is it? To get this one. Well done. Why? Why do you do that? Tell me. Quickly. Probabilities add to give you 1. Where? On a branch, right? So if this is 0.3, then what is this one? Say it. 0.7. Well done. So we know that this, to get this, you say 1 minus 0.3 to get here. You say 1 minus 0.3. Probabilities on a single branch should add to give you 1. That's good. So if you have this one to get the other one, you say 1 minus this one, you get the other one. So it's going to be 0.7. Well done. What about here? What do we do? We say 1 minus 0. 1 minus. Then what do you get? 80? You get 0.4. What about here? 80? It's 0.4 as well, because it's exactly the same as this one, because we are on the second one. Right. Now let's do BI. Both probabilities, now they're starting to ask us probabilities. We have done the tree diagram, so you should become very good. You should be very good at doing the tree diagram. So, yes. Well done. Probability of both red is going to be probability of red and red. This is going to be probability of red times probability of red. This is going to be 0.3 times red in the second one, 0.6. Well done. So I'm happy. The first thing you must make sure you do is know what both means. We want to use the keywords and the keyword or. So if they say probability of both red, it means red and red. Because both are red. Both are red. So it's red and red. Good. And is to multiply. So it's probability of red times the probability of red, which is 0.3 times 0.6, and you get 0.18, right? Well done. The second one, probability that neither is red. So probability that neither is red, let me teach you right now. When you do neither is, it is always, when we say neither is, it means we don't even want red. So it will be probability of neither red. This is the same as saying probability of not red and not red. Are we together? Probability of not red and not red. And the word and means you do what? Just like we did here, you multiply the probabilities. So it's going to be probability of not red times the probability of not red. Which is going to be, what is the probability of not red in the first one, students? 7. Times, what's the probability of not red in the second one? It's now Vic, isn't you should be changing. 0.4. Yes, you must be swapping. You must be swapping. One says this, the other one. Then what do you do when you do this? 0. What? 8. The first light is red, but the second light is not red. So the first light is red, so that means probability of red, and the second light is not red, so probability of red and not red. This is going to be probability of red times the probability of not red. What is this going to be? Probability of red, what is it? The first line, 0.3. Times, what is not red on the second light? Because it's red and not red. What is it, Vic? 0.4. Well done. I love it. Now you guys are moving together the way I want. And what is the solution? 80 is now your turn. What's the solution? 0.12. So you get it? You should use these words and know how to change. Probability that only the second light is red. So it's probability that only the second light is red. Only the second light is red. Probability of not red in the first one and red in the second one. Only the second light is red. So it's not red in the first and red in the second. Only the second. That is why we made the second be red. The first one is not red, and the second one only will be red. So probability of not red, and you say times. Then red in the second. Which is probability of not red, 0.7, and red in the second, 0.6. So let's do it. 0.7 times 0.6. What is this? 0.42. Well done. Well done. C, show that the sum of probability in part B is 1. Let's add. Sum will be equal to. Let's add the probabilities. 0.18 plus 0.28 plus 0.12 plus 0.42. What is this going to be? Well done. Any question? Any other question? Are you sure? Nine. Zara is bird watching. Blah, blah, blah. We don't care. Plot A. Copy and complete this tree diagram. So this is the tree diagram we need to copy and complete. Yes, no. Yes, no. Blackbird. Robin. Here, blackbird is 0.9. Robin is 0.8. Now, we can easily get it for anything. We are good now at completing it. The first thing we know is that when we are doing one tree diagram, how do you come from one to another? When we have this, to get this one, we say 1 minus this one. What do you get? What's 1 minus 0.9? 0.1. What's for here again? What's 1 minus 0.8, Vic? 0.2. If this is 0.8, this becomes 0.8. 0.2, this becomes 0.2. B1. Work out the probability that Zara sees both birds. Probability of both birds. In other words, is he going to see a bird the first time, a black bird? Yes. So it's probability of yes. And is she going to see a bird the second time? Yes, because she's going to see both birds. So it's yes and yes. What is that going to be? What is yes the first time? Okay, wait. Yes and yes means what in terms of maths? It means yes times probability of yes. Which is probability of yes the first time? You said 0.9. Well done, 80. What about the second one, Vic? 0.8. Well done. I love the way you're paying attention. This is amazing. And what does this become? 0.72. Fantastic stuff. Probability that Zara sees neither bird. Neither bird. She's not seeing a bird. So that means you say probability of neither bird in terms of our tree diagram is no and no. She is not seeing a bird. So probability of no and no, which is probability of no times the probability of no, which is going to be what, class? What is no in the first one? 0.1. Okay. Times what is no in the second one now? 0.2, which becomes 0.02. Are we together? See? Work out the probability that Zara sees at least one of the birds. Zara sees at least one. So let me help you this one. The moment you see at least one, remember this, okay? Listen closely. The moment you see them say at least one, it is going to be probability of at least one is going to be equal to 1 minus the probability of neither. Okay? Are we together? If you see neither, that means you don't even see one. So at least one is going to be 1 or 2. It's easier to get it by saying 1 minus 0. 1 minus the probability of meeting no bird at all. So this is 1 minus, since we've already found the probability of neither bird, what is it? 0.02, right? And you get it as 0.98. That's the probability of at least one of the birds. Let's do the very last one, and we are done. Here, if we do this, first, blue, yellow. Right. Now, blue on the first one is in the, they're not going to fool us, eh? Blue in the first one, they've put it on the spinner. They said on the first, blue is 2/3. So, okay. This is actually easier than all of them because they are telling us yellow on the first one also. So we don't even have to say 1 minus. Everything is given. Blue on the second one is 1/4. Yellow on the second one is 3/4. So we have it lastly 1/4, 3/4, like that. Yes? Then now we can answer the questions. We have copied and completed it. Now we can answer the second one. Let's go for it. This now says, work out the probability of landing on blue both times. So now we want to find out this one. Blue both times. So what is blue both times? What is blue both times? 80. What is blue both times? What do you understand whenever you see the word both? What does it mean? Yes, it means blue and blue. Doing blue both times. Which is probability of blue times the probability of blue. What is this? What is probability of blue the first time? 2/3. Times blue the second time. What is blue the second time? 1/4. And do you know how to multiply fractions? Yes. The top multiplies the top, the bottom multiplies the bottom. 2 times 1, 2. Over 3 times 4, 12. Reduce this to lowest terms, Vic. Now let's do the second one. Probability of yellow both times. How do you get it, students? How do you get this one now? Yellow both times. What do we do? What does it mean? Vic, what does it mean? It means yellow and yellow. That's what it means for yellow both times. It means yellow and yellow. Well done. Because it's yellow both times. So all the time. And how do you change end? What does end become? 80, come on. Where are you? Yes, it's a multiplication times yellow again. Which is going to be, what's the probability of yellow the first time? 1/3. Times, what's the probability of yellow the second time? 3/4. What solution do you get now? Yes, 1 times 3, 3 over 3 times 4, 12. The top multiplies the top, the bottom multiplies the bottom. 3 into 3, 1 into 12, 4. So your final solution is 1/4. Are we together? What is the next one saying now? Vic? Time. Come on. Blue at least once. Right? I want to make sure you're paying attention when I do that. When I ask, quickly, okay? AT, you can do it. The moment I ask, you have to prove to me you're paying attention. Okay? Probability of blue at least once. What does this mean? How do you do this at least once? What did I say about this at least once? How do you get it? How do you get this question of at least once? Yes, we're supposed to subtract 1 minus what? Probability of neither, okay? Yes. So 1 minus probability of neither being blue. 1 minus the probability of neither being blue, which is going to be 1 minus, what is the probability of neither being blue? Did we get it? It was yellow and yellow, right? Yellow both times, right? For neither being blue, it's like being yellow and yellow again, which is yellow both times. So 1 minus the probability of yellow both times, which is 1 minus 1/4, which is 3/4. Are you seeing? Probability of yellow at least once. Probability of yellow at least once. What is it now, class? 1 minus probability of neither yellow, okay? Neither being yellow. If it's yellow, that is at least once. We say 1 minus neither being yellow. Do you understand? If we want probability of blue at least once, we say 1 minus neither being blue. That's the only way. Are you hearing me? That is the way I want you to do. Vic, are we together? AT, are we together? Thank you. So this becomes 1 minus, what is it when they are neither blue? It means they are what? When they are neither blue, what does it mean? When they are neither yellow, rather. When neither of them are yellow. The first is not yellow, the second is not yellow. What can we say? It means both are blue, right? So this is 1 minus the probability of blue both times, which is 1 minus. What's blue both times? Which is by the way, they did give you another number 3 in here. It was a bit of a mistake from the book. Let's do it again. Probability of blue and then yellow, which is going to be equal to, what is it? What is blue and then yellow? 80. Give me the values. Vic. Blue, 2/3, and then yellow. That's more like it. You see? That's what I want. Quick answers like that. Because I know you guys can do it. And how do you multiply fractions? Vic, no, 80. Good. The top multiplies the top, the bottom multiplies the bottom. 2 times 3 at the top there. 6 over. 3 times 4 at the bottom. 12. 12, which is 6 into 6, 1 into 12, 2. So it reduces to half. Well done. Let's do the last one. Number 11. Here, they didn't give you a tree diagram. Here they say show the probabilities of the different possible in a diagram. So let's do that. She throws a ball at a hoop twice. So you can show them like Zara throwing the first time and throwing the second time, right? The first time, the probability that she gets a basket the first time is 0.4. So either it will be basket the first time. If it's the other one, will obviously be what? No basket, right? Then the probability that she gets a basket the second time. So she now throws again. Okay. Basket. No basket. Basket. No basket. Basket the first time, 0.4. Basket the second time, 0.9. Are we able to complete everything else from here? Students? Yes, we are. How do we get this one? 1 minus 0.4. What do you get? 0.6. Vic, this one? 1 minus 0.9. What do you get? $0.1. What about here? It's exactly the same as this one. 0.9, 0.1. Let's get to work now. This was A. We now do B. What is the most likely outcome? What is the most likely outcome? What is the most likely? It will be probability of no basket the first time and basket the second time. Is it not? No basket the first time is the largest, 0.6. And basket the second time is the largest, 0.9. So it's probability of no basket times basket the second time. What is no basket? 0.6 times what is basket the second time? 0.9. Then what do you get? 0.54. Can you see the part C now? It keeps coming. Find that you get at least one bucket. One basket. Are you seeing? Probability at least one basket. It is what? 1 minus, how do you get probability of at least one basket? I've said it many, many times. How do you get it, Vic? At least one basket. One minus neither. Neither what? Yes, neither basket. Are you seeing this, Vic? How do you get at least one? Yes. How do you get probability that at least one will be blue? One minus neither being blue, right? How do you get 1 minus at least one red, Vic? Red, right? 1 minus neither being red. How do you get probability of at least one green? Yes. How do you get probability of at least one black? Good. So how do you get at least one basket? Yes, 1 minus neither basket, which is 1 minus, when it's neither basket, if you come here, if you say neither basket, it means no basket and no basket, right? So 1 minus probability of no basket and no basket. So which is going to be 1 minus No basket and no basket is probability of no baskets times probability no basket. So it is 1 minus, what is no basket? What is no basket here? 0.6 times, what is no basket, the second one? Well done, 80. 1 minus, what is this? 0.6 times 0.1? 0.06. 0.94. Are we together? So are we good here? Okay, good. Let's do mean, then I give you work to do right now. You submit it before we meet again. Can you see here? Right. Right. Work out the mean number of people late per day. Are you saying? Can you see here? So here is how you find mean. Watch closely. I'm going to be teaching you one by one. When you see things here, look at this number 1. Look closely, boys. These are the numbers of people who were late for work. They're telling you each day how many people were late each day. 1 was late here, 5 were late here, 0 were late here, 2 were late, 0 were late, 1 was late, 3 were late, 6 were late, 1 was late, 0 was late, 0 were late, 0 people were late, 0 people were late, 2 were late, 0 people were late, 2 were late, 4 were late, 0 people were late, 4 were late, 2 were late, 1 was late, 1 was late, 0 were late, 6 were late, 0 were late. Are you seeing? So how do we now find the number of people that were late? Here's how you find mean for anything. Yes, sum divided by the total number of objects, right? Well done. So you add all of them, then you divide by how many they are. Good. So let's see how we do it here. Number 1. So it's always to add. Add. I want to see a plus sign there. Then you divide by how many they are. Are we together? 80. What should you always do at the top? Yes. You should always add. Then Vic, what should you always divide by? Yes, the total number of objects. In other words, what is that? What does it mean to say the total number of objects? We divide by what? How many they are. Okay? What do we do at the top? We add. I want to see a plus sign. Then at the bottom you divide by what? Yes. How many they are. So now let's go. Mean is going to be the sum. Let's add. So here's what you do. You look for the smallest number. You see how many times it's there. How many times do we have 0? Because we want to be adding, but when you're adding, you should always do one number at a time. How many zeros do we have? 1. Can you see? Let's count. Let's count. Come on. We don't have time. Move, boys. 1. Then this one. 2. Then the next one. 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 How many zeros do we have? 9 zeros. Plus. Let's do the ones now. How many ones do we have? Let's go. 1. Let's go. Count with me. Count together. Come on now. Let's go. How many ones do we have? Then the next one I've cancelled in green. It makes it how many ones? Let's go. How many ones are there? Let's count them. The first one, I cancel 1. 80. We are doing together. 1 in blue. The second one. Vic and 80. Come on. This second one I've cancelled. 2. We need to do it fast, okay? We don't have time. Let's do the next one. Here, 3. Then this. Then this. So how many ones do we have? 5. Plus, because you said you're adding. So you got to add. You said you're adding to find the mean or the average. Look for the next number. What is the next number if you go by size? 2. Let's count them. Four. So there are 4 of them. 1, 2, 3, 4. Well done. 4 what? 4 2s. Plus, let's count the next number. What is the next number? It's 3. I'm canceling it in black. 1. Oh, they're finished. We only have 1, so you just put it as a 3. Plus, let's go for the next number. One, then 2. So it's 2 4s. The next number is 5. And we only have 1 of it. Plus. Let's do here 6 and 6. How many are they? 2. 2 6s. Then we divide by the total number of things. Usually they'll tell you 24 days. So it's divided by 24. You could have counted each and every one of them to find how many they are. Now tell me, please. 9 by 0, 0. 5 by 1, 5. Plus 4 by 2, 8. Plus 3. Plus 2 by 4, 8. Plus 5. Plus 6 by 2, 12. Then 24. This is going to be what? 8, 16, 24, 29, 41 over 24. Are we together? Have you seen? Well done. So have you seen how to get mean for this type of information? I'm going to give you to do mean for this type of questions. You need to do it for me neatly, okay? And send it to me before we meet after lunch. Are we together? All right. We meet at exactly 2 p.m. I don't want any excuses. Thank you. I'll send the work. You do my work. 30 minutes break. Then you do my work. Okay? Then we meet. Thank you.